Before we can start to differentiate inverse Trigo, we will need to know how to use the calculator to compute the inverse Trigo values. Look at slides 7 and 8, you will find these examples there. So can you please take out your calculator and try for part A and part B. According to the slides 7 and 8, you are supposed to give your answer in degree to 1 decimal place. Try it. Now you should get the following answers to 1 decimal place. How about cotangent inverse and secant inverse, etc., where you can't even find the button cotangent and secant in your calculator? So for this, you will need to apply some rules. These are the rules that you will need in order to find the inverse Trigo values for cotangent inverse, secant inverse, and cosecant inverse. So let's take a look. Cotangent inverse 4.97, according to the rule here, it should be written as tangent inverse 1 over 4.97. So you press the calculator and see what answer you get. Similarly, for secant inverse 2.89, according to the rule here, it should be cosine inverse 1 over 2.89. So press the calculator. Check that you have the same answer as me. Now we are going to start differentiation. Let's take a look at the rule. These are the rules to differentiate sine inverse, cosine inverse, and tangent inverse. And there is a chain rule involved here. So let's look at the first example on slide 11. Differentiate this. Now, in this case, if I were to compare this question with the formula here, I will imagine this is like the u. So if I were to differentiate this, dy dx will be equals to 1 over square root 1 minus u square. So 1 minus u is 2x here, whole thing square. Then differentiate u, which is 2x. That's what it says, right? So simplify this. Differentiate 2x is just 2. Let me put on top of the numerator. And then simplify this 2x bracket square is simply 4x squared. That's all. The next example on slide 11, part B, is slightly tougher because there is a product rule here. So we got to now consider keep and differentiate, then differentiate and keep. So let's start. Let's first keep x squared and differentiate cosine inverse square root 1 minus x squared. This is equivalent to the u. So if I will differentiate this, I'll get negative 1 over square root 1 minus u square. If I were to square this square root, the square root will disappear. Then now I must differentiate square root 1 minus x squared. That's the u. I'm not done. Now I have to keep cosine inverse and differentiate x squared. So I have, let me squeeze a bit. Now, to simplify this, let's do this slowly. 1 and 1 will cancel. Negative and negative will become positive, and you have a square root x squared. So square root x squared is simply x. So this part will simplify to an x, and this will cancel with an x. So I'll be left with a negative x on this side. If I were to differentiate square root 1 minus x squared, power half will bring down, power reduced by 1, and then by chain rule differentiate the inside, and this part I will just copy Now, let's simplify this even further. I have a 2 which will cancel with a 2. Negative x multiplied by negative x is positive x squared. Let me bring this down to the denominator and copy the rest. That's it.